The Import tab is used to load a loudspeaker measurement, adjust its time alignment to remove any bulk delay, and get the phase response in a range we can work with on subsequent tabs. One way to load measurements is to live stream and capture data using the built-in Smart Control function. But for this tutorial, we'll manually load a saved measurement file. Here's a measurement of a full-range 12-inch two-way horn-loaded loudspeaker. The magnitude response is shown in blue and the phase in red. Use the response checkboxes to hide or show specific responses. Let's first remove any bulk delay using Find Peak. The magnitude is automatically offset by default, so that the maximum frequency is set at 0 dB. To manually change the magnitude level, uncheck Normalize Magnitude to Max and adjust the Magnitude Offset dB setting. Optionally, fractional octave smoothing can be applied. It can be calculated using either the complex measurement response, which includes magnitude and phase, or just the power spectrum, which ignores phase. We recommend power smoothing to avoid the loss of level that often occurs with full complex smoothing. Filter design usually requires both magnitude and phase, but in rare cases only one is used. Choose magnitude only to flatten out the phase and convert the measurement to linear phase. Choose phase only to flatten out the magnitude. This measurement shows how the high-frequency driver lags the low-frequency driver due to the depth of the compression driver inside the horn. Much of its phase is relatively close to 180 degrees. We have a few choices in moving the measurement to make it usable. We can align to the low-frequency driver, but then the bulk delay on the high frequency appears as high phase slope, which is hard to correct with filtering. Alternatively, we can invert the measurement using the Flip Polarity checkbox and align to the high frequency. This puts most of the phase near 0 degrees. Adjustments to the delay can be performed with the slider, plus and minus buttons and delay number fields. Another optional function is time windowing around time 0, which is applied before fractional octave smoothing. This function has various fixed-length window functions, from boxcar to Kaiser-Bessel. Their fade-in and fade-out regions can be adjusted via the start and end settings. The function also has a frequency-varying time window, which is longer at low frequencies and gradually becomes shorter at higher frequencies. The Import tab shows the two most common plot types found in FIR Designer. The upper is a magnitude and phase response plot, with a magnitude level range indicated on the left and the phase range on the right. The level range can be adjusted with the drop-downs or combos, and the plot can be zoomed by selecting a region with the mouse. Right-click the mouse or click Max to return to full view. The plot can be saved as an image file or as a text file containing columns of plot data. Both the plot response and saved text data is approximately equivalent to 1/96th octave frequency spacing. The lower plot displays the impulse response. The vertical scale can be zoomed using the plus and minus buttons, and the time range can be customized in either samples or milliseconds. Plot colors can be customized by right-clicking on the color next to the checkbox, which brings up a color picker. In Preferences, the plot line thickness can be adjusted, and all plot colors can be reset to defaults. Also, the frequency grid of magnitude and phase responses can be changed from logarithmic spacing to third octave. Loudspeaker impedance can also be loaded on the Import tab. The min and max ohms numbers are used to scale the impedance level shown on many of the frequency response plots in the workflow. You can now see the impedance on the upper plot. It can be enabled and disabled at the top here. That's it for the Import tab.